Today we're going to talk about something that can be challenging for a lot of folks in mathematics. That's taking something that's written in English and rewriting it in the language of mathematics using numbers and symbols. The first thing we need to understand is the difference between an equation and an expression. An expression is simply a statement. For instance, 3x plus 2. An equation, on the other hand, shows an equality. 5x equals 8. It shows that two things are equal, or an equation has an equal sign. Notice the first several letters of equation are the same as the first letters of equality or equals. There's several examples for you to try. Identify whether the written thing is an equation or an expression. Please pause the video here and let's take a look and see how you did. Let's take a look at the answers. On C, we have 2x minus 6 equals 4x minus 7. That has an equal sign. It's an equality, so it's an equation. D is x divided by 6. That's simply an expression. E, 7x equals 302. That's an equality. It has that equal sign, so it's an equation. Finally, F, negative 3y plus 2. That's not an equality, no equal sign, it's simply an expression. In mathematics, we have some things that we use. For example, here we have an unknown quantity. An unknown quantity we represent by a letter. We call that letter a variable. Anything that we plug into that we call a replacement set. So if I plug the numbers 1 through 10 in through here, the numbers 1 through 10 are called the replacement set. It's the things I put into that expression. And so let's take a look at some of the language of mathematics, some of the things that we should know that will help us identify how to write our equalities or our expressions. Here are some key words that are good to be familiar with. Words that imply addition, sum, added to, plus, increased, or more than. All of those words imply that something is getting bigger. Added to, we're adding something to it. Plus, increased, something is increasing, we're adding to it. So whenever you see any of these words, that should be an indicator that you're working with addition. Subtraction, on the other hand, when we're taking things away, things are getting smaller. Subtracted from, minus, diminished by, less than. Diminished by is one that folks often don't think of, and so that's a good word to keep in mind. You may see that periodically as you're working through some problems. Multiplication, there's only a few of them. Multiplied by, times, or product. And division, divided by, or quotient. Now it's a good idea to be familiar with these to see what goes with what. There are other words out there. There's a whole lot of them. But these are some of the most commonly used ones. Now, let's take a look at some examples of rewriting things from English into mathematics. Example A, we have 8 less than x. We have x of something, and we want 8 less than that. Picture this. Suppose we had 10, and we wanted 8 less. 10 minus 8. Suppose we had 100 and we wanted 8 less. 100 minus 8. Suppose we had 1,000 of something and we wanted 8 less. We'd have 1,000 minus 8. In this case, we have x of something. We want 8 less, x minus 8. Less than is a tricky one because when you write them, things are actually backwards from what a lot of people want to write them. It's actually x minus 8. 8 less than x. Example B, 5 more than y. Well, we have a certain quantity. We want to add 5 to it. We want 5 more. Suppose you had 10. If you wanted 5 more, you'd have 10 plus 5. Suppose you had 1,000. You wanted 5 more. 1,000 plus 5. Here we have y. We want 5 more. Y plus 5. The product of 7 and z. Product is multiplication, so it's 7 times z. D. X increased by 10. Increased by means it's getting larger. We're adding to it. We had x, we're increasing it by 10, x plus 10. These are some basic problems here. Now, let's look at a couple more that are a little more challenging. All right, let's jump ahead to m and n. On m, we have the sum of t and u divided by 6. So the sum of t and u, t plus u, divided by 6. So we have t plus u divided by 6. Over here on n, we have 100 decreased by twice x plus 5. Decreased by means subtraction. So we have 100 and we're subtracting something from it. So 100 minus twice is 2 times, x plus 5. So 100 minus 2 times x plus 5. Now there's a whole bunch more of these for you to try. I'm going to ask you to pause the video here and give them your best shot. Once you've done that, come on back, we'll check your answers. Alright, let's see how you did. We have for E, 20 minus n, F, W plus 1/2 W, G, 3 plus W, H, 3 minus W, I, R minus 2, J, 5R times S, or 5RS, K, 2x minus 10, L, 25 minus 4n, O, 5 plus m, and P, 2 times the quantity x plus y. Now, if you're not sure about any of those, put a star by it, and when you come to class tomorrow, we can talk about those, because sometimes these can be a little bit complicated. So any of them that were a little challenging for you, just make a star right next to it, or circle the number, and when you come in tomorrow, we'll take a look at those. Now let's take a look at things that can be a little more interesting, because while this is fun, it gets a lot more exciting. We're going to write some little equations. Here we have Larry, and Larry's age is 6 times Maria's age. Now the thing is, we don't know how old Maria is. If Maria is 1, Larry is 6 times that, meaning he's 6. If Maria is 2, Larry is 6 times that, he's 12. If Maria happens to be 10, well, Larry is 6 times 10, he's 60. If Maria is 20, well, Larry's 120, he's pretty darn old. So let's take a look at how we can do this. We don't know anything about Maria's age. And the thing we know nothing about, nothing at all, we use a variable for. We know about Larry. Larry is 6 times Maria. We know a little bit about Larry, but we know nothing at all about Maria. And so Maria we'll just call M. And you could use any variable to denote her age. It doesn't matter. We're going to use M for Maria. Larry is. The word is means equals. So whenever I see the word is, it means equals. Larry equals 6 times Maria. 6 times Maria. So Larry's age is 6m. And that's really all we're doing. We're going through and we're assigning a variable to the thing we know nothing about, and we're writing a little equation. Let's take a look at B. Today's temperature is 7 degrees less than yesterday. So if yesterday was 100, today's 100 minus 7. If yesterday happened to be 50 degrees, today is 50 minus 7. But we don't know anything about yesterday's temperature. I don't know if it was hot, I don't know if it was cold, I know nothing at all about it. And since I know nothing about it, I'm going to call it y. It's a variable. I know a little bit about today. Today is 7 less than yesterday, but I know nothing about yesterday. So, today's temperature is, so today equals 7 less than yesterday. Yesterday was y, because I don't know what its temperature was. So 7 less, y, minus 7. So today is 7 less than yesterday. And that's really all I'm doing. I'm going through and I'm writing a little equation to represent each of these. I'm going to ask you to pause the video here. There's several more for you to try. Take your best shot at them, and let's see how you do. Then we'll come back and check your answers. Let's see how you did. The first one we said the length is 5 more than twice the width. The length is, so L equals 5 more than twice the width. Twice the width is 2W, 2 times the width. 5 more plus 5. So the length is 2 times the width plus 5. D. Kim is 1 more than half Jerry. Well, Kim equals 1/2 Jerry plus 1. 1 more than half of Jerry. The sum of 2 numbers is 24. Now this one's tricky. 2 numbers added together give me 24. So we don't know anything about either number. The first number is x, the second number is y. And when I add them together, they equal 24. So x plus y equals 24. Now, let's get one of those variables alone. Let's say we'll get y alone. We subtract x from both sides, so y is 24 minus x. This is pretty cool because let's say x is 0. The other number, 24 minus 0, it's 24. If x was 1, 24 minus 1, the other number must be 23. Let's suppose x was 10. 24 minus 10, the other number is 14. And so the second number is going to be 24 minus the first number. That's a tricky one. F, we have a train traveling 1,000 more kilometers than the bus. Well, the train is 1,000 plus the bus. So train equals however far the bus went plus 1,000. If the bus went 10, the train went 1,010. We don't know how far the bus went. All we know is the train went however far the bus did, and 1,000 more after that. G, we have 5x. H, 24D. 24D, if you want to know how many hours in a certain number of days, just take however many days you had and multiply it by 24 hours. Each day has 24 hours. And finally, the number of days in H hours, well, every 24 hours that I had 1 day. So if I had 48 hours, 24 goes into it twice. So I take however many hours I have and divide it by 24. Those are some pretty cool little problems. Now, let's take a look at the last couple of examples because I put these in here because I think they're a lot of fun and I think you're really going to like them. They use averages, and averages are actually pretty fun to work with. Take a look at this. We have 2 brothers, Tim and Mike, and it says Tim is 20 years old. We don't know how old Mike is, so since we don't know anything about Mike, we'll call him X. The average age of the 2 boys is 17. Now remember, an average is when you add the numbers together and divide by how many there are. In middle school, we would have given you both of the ages and said find the average. But now we're going to give you one of the ages and the average and say find the other one. Well, the average of the ages is 17. So Tim's age is 20, Mike's age is X. 20 plus X divided by 2, because remember we divide by how many there are, and that equals 17. Now we use the multiplication property of equality, multiply both sides by 2, 20 plus X equals 34, subtract from both sides, and we get that X is 14. So Mike is 14 years old. Pretty cool little problem. Finally, we have a cool little thing, and I've actually used this before quite a bit when people come to me and say, you know, Mr. Dory, I want my final grade to be for the year to be a 92. What do I have to get the 4th quarter? And I can use a method like this to find that out. We have a student who has scores of 87, 92, 96, and 80 on the first 4 quizzes. There's going to be one more quiz. And the student says, I want my average to be 90. What do I have to get on this last quiz? Well, we can figure that out using algebra. We have 1, 2, 3, 4, 5 scores. The 5th score we don't know about yet. That's X. That's what we want to figure out. and we want their average to be 90. So the average, I take the 5 scores, 87, 92, 96, 80, and X, add them up, and divide by 5. That equals 90. Multiply both sides by 5, add up the numbers, and solve for X, and I find out that the score must be 95%. So if you want your quiz scores to be 90% for the quarter, and these are what you have so far, your last one has to be 95. That's a cool little problem. Working through these can be a little challenging sometimes. Some people, they come pretty easily to. Some folks, they have to work at it, and that's perfectly normal. When you're translating from English to mathematics, take your time, read the sentence a couple of times, think about what you're writing, and then once you've written, go back and see if it makes sense. That's really all there is to translating things from English to mathematics.